Hello, everyone. Good to see you. Thanks for coming today. I'm really excited to talk about this topic, Python for the .NET developer. The idea is going to be that I'm assuming you probably know something about .NET. Even if you don't, I'm sure you're going to learn some stuff. But assuming that you do, what are the things that are really cool over there that we either have similar or sometimes even better versions of in the Python space? So we're going to spend 50 minutes or so exploring that together. Now, first of all, I want to encourage you all to ask questions. At the bottom of this screen, there's a little question section. You can ask questions, comments on questions. And what's cool about Crowdcast is when I answer them, it'll actually be in the transcript. You can click it and jump back to the answer if you want. But let's start off with polls here. So if you go to the bottom, there's a poll right there that you can focus on. A couple of people have already answered this, a fair number of people, but I'll give you all just a minute to fill out these 3 really quick polls. They're just multiple choice. So check those off, and then I'll talk about the responses. So the first question is, my favorite thing about C#, which is the primary language for .NET, as many of you know, is the language, or ASP.NET, or Entity Framework. And this question, I think, is interesting because it gets at, if I was not doing .NET, if I was going to do some other technology, what would I miss the most? Would it be like, oh, PHP isn't bad, but boy, it doesn't have an Entity Framework, and boy, every day of my life do I miss that thing? Or, Python is great, or it's this other thing, or if you went to Java, Java's great, but, right? So by the wide margin, most of it's the language, and there's a smattering of ASP.NET, Entity Framework, and Windows forms down there. Interesting goes, gonna wait. My experience with C# is about a third of people are brand new with it, which is interesting. A third have been doing it for up to 3 years, a little bit less, 3 to 5, and then maybe not a third, but yeah, decent number of people have been doing it over 5 years. Cool. And then this last question is, I want to learn Python to, why do you want to learn this? And I think this is an interesting topic as well. Assuming that you're already a C#.NET developer, right, you don't need to learn it to become a programmer, right? So why learn another technology, right? We learn JavaScript because we all have to learn JavaScript because of the web and things like that. But you probably don't have to learn Python. You could keep going with C#. So why do you want to? All right, so that's what this question is about. Primarily, people said, I want to do this. 57% said, I want to do this to boost my personal career. A couple of folks said for a project at my current job, to change jobs, or also I just need a fresh breath of air around the technology. I need some fresh technology. So I think those are really interesting responses there. I feel like, my personal journey, I was a .NET developer for many, many years and enjoyed it. But the reason I started learning Python is I just thought, I really need to just, I know, right? It's great to know this one programming language and this one technology and be really good at it, but it would be great to know other ones. It would be great to know ones that are more native on, say, to the open source world, or on Linux or other platforms outside of Windows. When I was doing .NET, it was mostly just Windows. So, all right, so those are interesting. Thanks for giving that feedback for everyone. Now, let's go ahead and dive into the presentation here. There we go. And just to confirm really quick, you all can see the screen with the woman pointing at the heart, and you can hear me okay? Just somebody throw that into the chat that you can hear, all right? Yeah, Paula says, I came from C++ and noticed I could make programs much quicker and with more fun with Python. Yeah, I did a lot of C++ before I did .NET as well. Yeah, that's great. Okay, thanks for the verification, you all. Awesome. All right, so let's get started. First of all, I want to point out that all the materials and more that I'm going to present are available at this GitHub repository. I'll send you a link in the chat at the end as well, and a follow-up email even. But the examples I got here, I'm taking from my Python for .NET developers course, and that repo is over here. So instead of setting up a separate repo, I figured I would give you this one. It has the examples you'll see that we'll create, but it also has a ton more. So here they are. We'll put that out again. Now, first of all, I just want to talk about why should you care about Python, right? Maybe you should focus on Java because those are like similar interchangeable languages and technologies that'll let you move, say, over to Linux more easily or whatever, right? Maybe it's a better choice over there, or maybe you should just double down on JavaScript and go Node or whatever. So let's just talk really quick about why Python is a solid choice. Not the only choice, but certainly a decent one. And I'm sure you all are familiar with Stack Overflow. Stack Overflow is the Q&A place that we all spend a lot of time on, but they also do some reporting and analysis. They even just had, I think it's just open right now, their 2020 developer survey. So Google for that and check it out. But here I want to just show you some stats that they pulled out here. Actually, stats that I pulled out. So this is from Stack Overflow Trends, which is a search, kind of like Google search trends type of tool you can run over at Stack Overflow. If you look at these different languages on the screen here, over time, notice this is not just a little bit of time either. This is over the course of 10 years, over 10 years. Excuse me, a bit of a cough today. So this is 10 years of data. And if you look at these curves, including C# up there, many of them are not on paths that you would want to ride on if your career is riding on that path. Like I personally would want one that is rising and going up and whatnot. And one of these is unlike the others. It stands out pretty starkly that Python, ever since 2012, has just taken off and really has started to grow and get massive, massive adoption across all different parts of the industry. So one of my rules of thumb is if I'm going to invest in a technology and learn a lot about it, it's a good idea that it's increasing in demand and popular. And so, all right, so it's very popular, it's growing quickly. But what's interesting is why. There's a lot of reasons I think at play here, but it's a really easy language to get started, which is why a lot of folks get into it. But a lot of languages that are easy to get into don't let you build real apps or really super interesting things. But Python, on the other hand, is what I call a full spectrum language. It really lets you continue to build things like YouTube or Instagram or all sorts of other things that we'll talk about. So this is a really, really good trend. Chris says, I think that trend is because of me. Well done, Chris. Well done. So you can read their original analysis of this back to basically 2018, and they make some predictions. Interestingly, their predictions they seemed outrageously positive for Python. They were actually underestimating stuff. The Python graph was pretty accurate. The other ones are downward more than they predicted. All right, so I'm assuming that you know C# and .NET. We're not going to go into the background of that, but even if you don't, I think you'll get some stuff out of this. Now, one of the things I like to do is as I think about, Craig, it is interesting, goes on that graph. I didn't put it on there. I guess I should have. But I suspect that it's probably quite a bit down there. The other languages like Swift and Rust and whatnot they're like way, way down there. They're way less represented than you would expect. But yeah, you can throw it on there and let us know if you want on Stack Overflow trends. So one of the things I like to do is I like to think about, if I'm going to learn a technology, what could I build with it? Or if I was going to use it for a project, what other projects out in the world are built with things like that? So I'm going to real quickly just touch on a few things that are built with it. So SpaceX uses Python all over the place. I love this company. SpaceX is doing such cool stuff. And they have over 92 open positions for Python developers. That's a lot. They actually are super secretive and don't say, here's all the stuff you're doing with it. But they're definitely doing a lot. Spotify uses it. NASA is using it to get us to the moon, which is pretty awesome. Bitly is built with Python. Bitbucket, also Python. JP Morgan Chase has 35 million lines of Python, and they use it for a lot of their core internal trading engines and stuff like that. Quora is a great place. I love that Q&A place, and it's built with Python. Discuss. Instagram is one of the larger deployments of Python and Django. Reddit is built in Python. It's pretty awesome. Actually, Reddit's interesting because they actually have the whole Reddit site open source, not in the live, you can make PRs to it and stuff, but they have an archival version of Reddit that you can go and browse the source code of, which is pretty rare. YouTube, they receive millions of requests per second built with Python. Python package index, built Python, not super surprising. Pinterest, PayPal has their core, like a pricing engine that they use for like exchanging monies and stuff. I think it's called several billion times a day. Has to have like millisecond response time. That's built in Python. Dropbox, end to end is basically Python, even on the desktop side. And all of our stuff over at Talk Python, of course, is built that way. So here's a little link. You can actually go and check out a lot of the stuff they've written up, what people are doing with Python. So you'd be in good company if you were hanging out with these tech giants and whatnot. All right, now one thing I want to talk about before we get into the details, when you think about as a C# developer or .NET person, you think about Python compared to C#. What probably stands out to you is not how they are very similar, but how they are very different, right? You're probably like, well, there's no real meaningful use in the same way of curly braces. There's no semicolons. There's no compiling, not in the same like pre-compile before it runs, you know, to create IL sense of the C# compiler, MS build and all that. There seems like there's a lot of differences, right? One is typed, one is not typed, and so on. But as you explore it and as you learn it, I think what you will find is that they are dramatically more similar than they are different in a lot of ways, right? You'll see things like Entity Framework. There's very, very, very similar frameworks over in Python that you could, you don't quite confuse it for Entity Framework, but it's very, you know, you would be very comfortable as an Entity Framework person. Async and await, Python has async and await. The static typing stuff, you can actually put that into Python. There's many things that are quite similar. So I think that's probably the main thing I'd like you to take away from this is there's a whole what you might want as a .NET developer, things that you love that you don't want to miss. You guys said the language and a little bit of Entity Framework, a little bit of ASP.NET. And I think you'll find actually that there's really similar stories across the board for much of what you want. Lambda expressions, for example. Okay, so the first thing to talk about though, before we get started, and then we're gonna go write some code, is really just the differences, because the way that you structure a code in Python is very different than the way you structure it in a C-based language. At first, this will freak you out, but then over time, I think it's gonna really grow on you. I'll say more about that in a minute. So the way that we define like blocks of code and stuff in Python is not with curly braces, but with indentation. So for example, every colored box on the screen is a code block, and defined as a code block because it has indentation, right? So this is also referred to as suites in the parlance of Python. So for example, there's a method, some method, which takes a name, and because it has a colon and then it indents, if and the else statement are inside that method, and then that if statement has a colon, or more significantly, I guess, the else has a colon, and then you indent 2 lines, and those are in there. And when you stop indenting, it's not in there. The motivation for this is if we're going to use this indentation structure for readable code anyway, why not use it as the structure itself rather than having other symbols that get in the way? Like I said, at first, coming from some C language, C#, C++, JavaScript, it feels weird, but it gets really nice, right? Like you'll see the not having to type a semicolon is actually really nice. It feels like you need to, but often you don't. So the first thing I want to do is go over here and write some code. Let me see if I can get this thing off my screen so we can work with it. Okay, now we're going to do a couple of things. First, we're going to come up and do a little bit of a fun app. So I've created this starter project. For the most part, we're going to look at a C# version and then the .NET version. But for this first one, there's not really a meaningful parallel. We could have it, but it's pretty simple. So I'm going to come up with this simple little program that we're just going to say, given a jar of M&Ms, let's just guess how many M&Ms are in the jar. And by the way, this editor is called PyCharm. It's made by JetBrains. If you use ReSharper in Visual Studio, then this is like the IDE that the ReSharper people made. All right, so let's go and define a little program. And what I want to define is a program that says, there's some number of, you have some M&Ms, how many M&Ms are in my jar, right? You've probably played this game at a party or something. We did this at a Super Bowl party not long ago, and whoever got closest won. But we're going to do it. You have to get it exactly right, but the host is going to give you, or the computer is going to give you some guidance. So we need to first start by having a library. In .NET, you'd say using system, right? Something like that. In Python, we don't have using, but we have the same idea, basically. We just call it import. And what we're going to do is import the random library. Now, I just installed some huge thing for this data science stuff I want to show you in a minute. So it won't give me autocomplete until that little thing goes away. It's almost done. So give it a sec. I'll just keep typing and we'll come back. All right, so we're going to import this random library, and then we need to come up with a number. We also probably want a little header, so let's do a little print. This is like console.writeLine, like so. Yeah, we're going to print, I don't know, whatever we want to print. A couple lines here, and M&M guessing game or so. That's cool. And then once we've got our little header, we're going to need to create the number, the count or something like that. So we go over here and we say random. Again, this would have autocomplete if I didn't. I saw this huge thing for like this data science stuff, so it's going to take a second. So we'd say rand int, and you got to put in, let's say it has a 1 to 100 just to keep it bounded or whatever, right? And just to, one thing I like to do to make sure I'm on a good path is I like to just print out or write to the console little bits as we're going, the count over here. Now in C#, you can do this, and then you can have like within these strings, right? You can put little curly braces, we count. But over in Python, we don't have this. We have this, we have F. So they're called formatted strings. And once you have formatted strings, then you can just print them out like that. Oh yeah, this indexing thing is looking like we're there. Cool. So now, like if I type random, right, you get autocomplete, just like you would expect. It just happens to be, it was recomputing that stuff, and PyCharm doesn't, I don't know, it doesn't let you get what it already knows. Cool. So let's go ahead and run this. The way you run things over here is you just right click and you say run. And once you've done that, it's up here and you can click this button. So right now, the first time it's 54, 31, and so on. All right, well, it won't be very fun if we do that, right? So the next thing, let's just come over here and say you get 5 attempts to guess. So we'll do attempt limit. Now, one thing that will freak you guys out as C# developers is this is not int. This is just like so-and-so. It's not var, none of that. But these types, these variables, they do have types associated with them. Like this is an integer. And if I tried to do like attempt limit plus this or whatever, it knows that integers and strings don't go together, right? So they're there, you just don't say that in the syntax. So let's just do attempts. We'll just knock this out really quick. So what we want is a while loop, right? That's pretty standard, same in both languages. We'll say we want the attempts is less than the attempt limit, like so. Now here's where it gets different. Watch if I hit colon, I might think this is weird, this indentation and stuff, but what you'll see is with editors like PyCharm and VS Code and so on, they all know about the structure and they make it entirely transparent. So if I just hit enter, right, it's already done the indentation for me and so on. So we could start by just saying attempts plus equals 1, and then we could get a guess from the user, and instead of console readline input, and it's just what is the count, right, something like that. We need to convert it to an int, so let's just do that in one line. And then we can just say if the guess is less than the count, and we just print out too low, else. Now, there's not an else if in that regard, tightened up to just elif. The guess is greater than the count, and print, what did I hit? Print too high. And then if it's not too high, it's not too low, it's Goldilocks, right? Spelling is hard though. Okay, print let's just, yeah, print. You got it. There were however many. I always forget to put my F at the front. There were the count M&Ms. And then we just do a break. And something like this, print, game over, and what I say about those Fs, attempts. Cool, right? So pretty straightforward code. Now, one thing to take away is just notice even though we use this indentation structure, I never fiddled with the indentation. I just wrote the syntax in the editors already do it. So I just want to really point that out, that like, you don't manage this, all right? The tooling that hopefully you're using does. So let's run this. What is the count? It is 50, it's too high, 25, too high, 10. Oh, I nailed it, 10. That's pretty good, 3 guesses. All right, so this is the basic way that we write Python code. And there's a lot of things to learn here. We've got this import, which is the equivalent of using. We've got print, which is the equivalent of console write line. We create variables without saying their type, but they do still have a type, right? It's not like JavaScript or something like that. At runtime, they effectively have the same type behavior as C# does, right? Got our cool while loop, got our if-else if. It's quite similar. We have no semicolons. We have these colons and indentation instead of curly braces. Another thing that's interesting that'll probably freak you guys out at the beginning, but eventually you'll come to really appreciate, is that I didn't have to write this either, did I? Now, PyCharm is saying, like, this will run. It won't break or anything. If it made you feel better, you could do that. You could also even put semicolons at the end. Those are allowed as well. They'll run still, see? But they're not really encouraged. And the thing is that with all these if statements and stuff, you don't need these parentheses. Now, C# like be there, like this is the essence of programming, is these things get these parentheses and so on. And yet, they're not needed. And so what I found was when I went back and worked on other C# projects after I'd been doing Python for a while, it was very frustrating to type all these things. I'm like, actually, all these symbols I'm typing, they're not needed. Yeah, so anyway, this is our first little project that we're going to write. I want to just kind of explore some more ideas with you. So this next one over here, I'm going to write another one. Go ahead and set it as the target of execution. Can't really do that in Visual Studio. You just have like a public static main void, and you have to tell that one which one to pick and so on. But in this one, I want to start out looking at the C# code. So let's fire up Visual Studio for Mac here. I'll take I don't see any new questions coming in, but I will take a moment and answer questions in a little bit. So let's look at this. Takes a second for Visual Studio to do its thing, but eventually it will come to life. All right, so what I want to do is I want to build a little generator, and my favorite generators are Fibonacci's, because those actually serve a lot of interesting purposes in exploring some of the language features. Okay, so Fibonacci numbers, for those of you who don't know, is just the numbers 1 and 1, and then you take the last 2 numbers and add them up. So 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 is 8, and so on. Quick question, are variable types inferred from the value it's signed, similar to how C# infers it? No, not exactly. Variable types, let me see if I can show you this real quick. Maybe this will point out a little bit better. There's a place called pythontutor.com. And it lets you visualize your code, which is kind of cool. So if I come over here and let's set this to Python version, view, native Python view rather. If I have x equals 7, let's do this. Age equals 7, name equals Michael, not really 7 in case you're wondering. We'll have people equals name, Sarah, and Jeff. All right, so this thing's kind of cool. You come down here and you can say visualize my execution and like step through it. So here's maybe the picture to take away. Like these variables, they don't know what type they are. They don't have a type. There's literally, they are a key in a dictionary called a global frame. Yeah. So they're not like inferred like C# is a var, but you don't say the var. It's not like that. They just point at a thing. Everything is a pointer. Everything is a reference type. Even numbers are reference types in Python. So they just point at a thing. but the thing that they're pointed at has a type. Like this is an integer, and this is a string, and this is a list. So when they interoperate together, like if I pass name to a function, it doesn't know that the name variable has to match a string or whatever. You can do that. We can show you that in a sec. But it's more that the data element itself knows its type. Just like C#, also, it has like all the objects that are acted on by like GC and whatnot. Those have like a little type pointer on their structure in memory as well. So they know what they are. It's more like that. Hopefully that answers your question. Okay, so let's look at this little Fibonacci thing, because I think there's a lot of interesting things to take away from it. So here is a C# program. It's going to run. It's going to say generators. It's going to call this infinite sequence Fibonacci. It's going to use one of my favorite features of C#, yield return. Going to return an IEnumerable of int called Fibonacci. Here's the algorithm to generate it. You got these two numbers and you add them up like this. You do your temp swap, yield it back, and go on. There's also this one that's not infinite, that doesn't use yield, but it's not as good. Okay. So this is cool. We can run this real quick. And it should indeed give us the first set of Fibonacci numbers up to 1,000. But what I want to do is also build this in Python, and there's just a couple of cool takeaways here. So let's go over here. We're going to define a function. I want to kind of keep it similar. So got our main. All right, so we'll define a main method that's going to do the stuff. Instead of doing open close curly, the way you say this thing's empty for the moment is you say the word pass. I'm just call this fib. And down here, what we had was we said there's a current and a next. Next is actually a function in Python. You can see it's colored. So we're going to call ours nxt. But we can declare the variables like this: current comma next equals 1 comma 1. It's called tuple unpacking. So you can take these two values and put them here and here, kind of initialize it. And then we had our while true. This is very different than C#. C# looks like this. Python looks like that. And then what did we want to do? We said over here that we were going to go create a temporary variable, swap them, and then put it back. Because of this cool tuple unpacking, we can say current next equals next plus current, like that. And then over in C#, we had the yield return. We don't have yield return in Python. We have yield in Python, just means the same thing. All right, so that's the whole implementation for the Fibonacci sequence over here. And then we have some really cool stuff as well. I think it just said generators, so let's put that. Then, in C# we have such a cool way of looping through things with for each, right? For each, int n in fib is what we would write, yeah? We never see in Python. We would write for and in fib. Looks similar, right? Not exactly the same terminology, but really it's the same thing. It even has like a certain thing implement so your objects can be used as a data source in here and so on. And then we'll say if n is greater than 1,000, a break, else we're going to print. And now we do it this way. It's going to go line to line to line. Remember, that's like console write line. We want console write. And the way you do that here is you can say with a keyword argument that the end is not a new line, but is actually just going and like putting a comma to separate them. All right, that's it. Let's try to run it, see if it works. No, because I didn't call main. In Python, you don't have this concept of a static main void. We have this like kind of funky syntax that takes some getting used to say like, am I trying to run this program as a target of execution, which is what this is kind of like stand in for public static main void, then do this. All right, try it again. Look at that, identical output. Well, I guess to get identical output, we'd have to put that start at 0 and 1. Okay, so this is cool. Now, the reason I think this is really interesting here, let me take away the comments and put this away because this is actually not being done in the same regard. There's like another function that we're not going to show, but here's what I want to show you. I want to put this next to there, and I want to put this over here, like hide that puppy. Now I can't make that any smaller, so maybe I gotta move it to the side. But look at this. Look at how much symbol stuff is on the right. There's so much going on over here compared to this. Now we can scroll down to the implementation of the Fibonacci sequence, and that's this. All of that, right, is this. So here's one of the really important takeaways for this language. Like there's just a lot of stuff happening in the static languages like C# that is really important, is useful for large applications, but a lot of times it actually, after you get used to reading them both, makes it a lot harder to read. Like I did C# for 12 years or something, right? Like it's not like I wasn't accustomed to reading it, but if you look at all the stuff that's happening on the screen and all the stuff that's happening here, it's just simpler and it's just cleaner. And it's pretty interesting. There's a question about whether C# has infinitely large integers. Yeah, you've got to use a special integer type, as Craig is saying, yeah. But not by default, whereas opposed to like this current, I could make that, 7 peto whatever, right? Like some huge number, quadrillion, and it's fine. Like the integers are always, they're always basically big ints capable in Python. Okay, well, this is pretty interesting. I think, yeah, I want you to have this takeaway. Like, look at all this stuff on the right compared to like trying to read the code on the left. It might not be as obvious if you're not completely used to reading them both yet, but I think it's pretty striking to look at these two examples side by side and just think about how simple things are. And it's not simpler necessarily because I don't have to say int in or whatever, right? It's more about all the curly, 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 semicolon, parenthesis, parenthesis, curly, semicolon, parenthesis type of experience. So when I went from the right to the left, the absence of that freaked me out. But then a few weeks later, going back from the left to the right, I'm like, wait a minute, why is all this stuff here, right? That was a really interesting journey for me. All right, so that's a pretty good one. Let me just sync us back up with our presentation here so that I stay on track. There we go. So we did our guess the M&Ms in the jar. We have this for in loop that we can use. We have super simple iteration that's very, very similar to what you have in .NET. All right, so we loop over stuff with these for in loops, then they have to be iterable and so on. Now, the other thing I want to think about is package management. So if we go over here, we can go to NuGet, and NuGet's pretty awesome, right? Like NuGet is the way that you get all these amazing projects. This is how .NET itself is delivered these days with .NET Core in large part, right? Entity Framework comes this way, ASP.NET comes this way, but also all the other things. And you have 187,000 packages. That's awesome. In Python, we have this as well. It's called Python Package Index over at pypi.org. We have 217,000 of these, and it's like 2,000 more in just the last couple weeks, maybe less than that, right? So that's not to say that this is better than NuGet or NuGet is better than this, but there's at least as much stuff over here in this sort of open source package install package type of world. And we have similar tools. It's not PowerShell install dash package. It's just pip install package, but the same basic idea, okay? Now, one of the areas where Python is used a lot, but also .NET is used a lot and it's really good, is in the web development world. So in C# and .NET, it's basically one choice. You have one choice for the web framework. So for example, if I go to my little Visual Studio and like create project dialog and say new web project, any form, I can create an ASP.NET Core app, or I can create a Blazor app based on .NET Core, or I could create an ASP.NET Web app that runs on web forms or MVCs on the traditional framework, or even a gRPC Google API exchange based on ASP.NET, and so on. Hopefully you're getting the point. Now, I'm a huge fan of Blazor, and I think what they're doing there is ridiculously cool. I wish we had something like Blazor in the Python world, but we don't. But nonetheless, I think the takeaway here is that there's really just a web framework that you use. In the Python space, it's not like that at all. There's like, it's the Wild West. I literally today, someone just sent me a message like, hey, Michael, have you heard about just py.io? Like, no, it's brand new, apparently. That's cool. So there's just frameworks everywhere. So we've got Django, we have Flask, we have Pyramid, we have Masonite, we have Starlet, we have Fast API, we have Sanic, we have Tornado. This is like a quarter of the active frameworks that you could pick from. These are all like playing the role of ASP.NET or ASP.NET with Web API, or some focused down variant of that. So that's pretty interesting. Yeah, so let's go, and I have more to show you in the web. I'm just going to build something with you. How are we doing on time? Good, good. So let's go put this away, make this big, and put it away, and open this thing called Guitari. So Guitari is a little app that I built for the .NET course, and it's like a guitar store or something like that. And notice over here, it's nice and factored. I gotta get this to stay out, I guess. Stay. There we go. So like we have a home controller. Here we have our index page and our guitars, and we're passing a string, which is an ID. It shouldn't really be called ID, but we call it ID because the default routes in ASP.NET, there's always some piece of data called ID that's passed. Really, we wanted to call it a style, so I created a variable called the style, create a little view model. I love to use this concept of view models in ASP.NET or any of the web stuff, and definitely in Python. And then we're going to render the view, right? The view, where's the view? It's this one. Let's look at the guitars, right? It's got this sort of default layout template. Come down here, it's got some buttons, and then it has a razor syntax at for each guitar, etc., right? And we're going to grab the value of the image, grab the value of the name, so on. So let's check this out. This is pretty fun. Takes a second to start up, but there we go. Let me make it a little smaller, fit the screen. So we go to check out our guitars, and cool, look at this. We have our Weezer Classic and our Mellow Yellow. We can see just the acoustic guitars, acoustic black, or just the electric. Notice there's no acoustic black. It was the cheapest one, so it's at the end. But if I go all of them, then it's down in this list. You can see that we can pass that data over to the style. Pretty cool, right? So let's look at how we might do something like this in Python. So put this just down. Actually, I need to stop it running because the ASP.NET core version that runs out of this Visual Studio runs on port 5000 by default, and so does Flask. So I just got to stop it for that purpose. So let's go back over here to our guitar thing. And actually, I have it up here already. Just run it. So let me just show you before I run it, though. Over here, we're going to use the Flask framework. You could use any of them. And check this out. Here's a little trick just so you can run it from anywhere and it can find its resources. So it's not really necessary, but it makes it easier so people can just grab it and go. So we're going to say we're using Flask, and we're going to use this data access layer called catalog service, just like we were over there. We'll initialize the app. Here's our home page, where we have no data to provide to the home page. It's just static, so we just do that. And then this guitar one, this is the same as you saw. Let me show you what it was over here. Why don't you want to come back? I don't want to hide you. There you go. That was this one right here. Is come back. This one right here. So we pass actually multiple routes to it because this doesn't have the default ID being none. Probably could set that up, but I didn't. But then it just passes the style because we say here's a variable style. It goes to the catalog, and then it just renders it. It's slightly different than the view model, but about the same. But here's the difference. This is like the entire application. Right? This is it. If over here, I've got this startup program that's installing all this complicated middleware. I've got this program that's doing like the host builder. I've got a whole bunch of stuff going on over in PyCharm. We just have this. Like this really should be in its own files, but I wanted to keep it simple for you, just kind of put it together. We also have a template over here. Come down, we have a layout page at the top. PyCharm thinks Guitar is misspelled. They don't know. We have a for in loop or for each loop, just like we saw before. We're grabbing the values. We don't use the at. We use double handlebars. But other than that, we don't use curly braces. We use end. Other than that, it's basically the same. So click over here, click around, go to our guitars. Here's our acoustic black. I changed the price in this version, I guess, but you can see super fast, nice example of our website. All right. Let me just double check the notes. Yeah. All right, so pretty interesting framework, pretty similar. Open source, 100%. You know, runs all sorts of places. I know .NET Core is these days as well, but this stuff has been from the beginning. And yeah, it's a really, really nice framework that has tons of plugins and support for various things. So this is the web story, and I think the web story is quite similar. And I'm not going to do like Unity Framework database stuff just because we don't have time, but it's very similar. You would use something called SQL Alchemy, usually paired with Flask, and it's like Unity Framework code first. It's almost identical to that. I don't use that myself because I use MongoDB, so I use a ORM-like thing called an ODM for MongoDB called Mongo Engine. So, you know, that would be like MongoDB's C# driver library. All right, now the last thing that I want to touch on here is the data science side of the story. So far, what I've told you all is kind of like, these things are really similar. Here's this really cool thing that's like this, and here it is over in this other technology, right? Here it is in Python, here it is in C# or vice versa. This notebook story is a little bit different. Now, it has been possible recently to start using .NET in what's called a Jupyter notebook, but this is pretty new, and the number of data science libraries supporting it is dramatically less than in the Python world. Remember that super steep curve that we saw that around 2012 going up? Many of those people who are coming in are coming from a computational sort of scientific or something like that background, not necessarily just data scientists, but maybe, you know, economists or biologists or something. And they've built all these incredible libraries for like talking to telescopes and reading genetics files and all sorts of stuff. So Jupyter, you can actually run both Python and C#, but the things you can do in Jupyter is much richer around the data science story in Python because of that. Okay, so let's look. I want to work on a little project here for this. Let's see. So I've got over here this notebook, and if you open it up in PyCharm, it'll actually open up, and it says Jupyter's not installed. I'm not entirely sure about that. I think it was. Pretty sure I ran it. Anyway, over here, you can run it here, and there's this kind of like thing, but it runs an older version of Jupyter, not Jupyter Lab, which is the newer version and whatnot. So I'm just going to go, let's just go over here and open a terminal here. Maybe I'll do it like this, so it's more obvious. Okay, I need to activate the virtual environment. This is like kind of like side by side or xcopy execution. So give me a second. There you go. Notice the prompt changes, and you can ask this little tool what's installed. And is Jupyter really not here? No, Jupyter's here. There's all sorts of Jupyter. Okay, anyway. Maybe not Jupyter, but Jupyter Lab. That's what I want anyway. So we'll say Jupyter Lab to kick this off. And notice it just kicks me over to the browser. But if you're back here, it's like running a server locally. And I don't want this Lawrence thing at the moment. What I instead want is I want to do a little tiny bit of data exploration to give you all a sense of what it feels like to kind of be a data scientist over here in the Python world. So what you have is you have this. Maybe I'll show you the Lawrence one first, just so you get a broader sense. So you've got Markdown and other text. You can put pictures. You can put all sorts of stuff. You can even put LaTeX for like fancy math, official math, like with integral signs and partial differential equation symbols and icon characters and so on. So we can put those there, but then you can also get these cool graphs. And for some reason, why is this not showing up? I've got to install this extra thing, and that's what I installed. That was taking forever, but I guess it didn't show up here. Maybe if I refresh it one more time. Let me do one more run. There's this like a cool little, there you go, exploration thing that I was looking for. So there it is. So you can even get these like interactive widgets that you can play with to change the numbers that then drive various things. Okay, so this interactive thing. So this is really, really different than programming. The idea is like, I'm gonna do a little bit of thinking and writing, then a little bit of data exploration, then a little more writing. It's almost like writing a paper, but the exploration side is interesting as well. We've got graphs. So what I want to do in just a couple minutes, really, really briefly, is I want to go to one of my podcasts, pythonbytes.fm, over here. And we've got a ton of episodes, 167. And within each one of these, we're referring to different places. Here, 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 over here. We're referring to this, the Russian police raiding the Nginx place, and all these different places are getting referred to. So what I want to do is come up with like a rank, like what sites or domains do we refer to most, to say like we give them the most Python credit or whatever. So here's what I want to do. And how much time do we have? A couple minutes. I want to spend a couple minutes and just actually download, parse the XML of the RSS feed, do some queries to pull out the elements from that RSS feed, and then get a hold of all the domains out of the HTML, the pretty HTML that's embedded as the show notes for each episode, and then plot and graph and do a little data science with those. Okay, so first thing we're going to do is we're going to use, notice you can just come down here and type code, and you can even hit that, and if you hit tab, thinking, there you go, you get like autocomplete, IntelliSense. Sadly, you have to hit tab. It doesn't do it when you just hit dot. So what I want to do is I want to download and parse this into a feed. So notice I'm using two libraries, Beautiful Soup 4 and Feed Parser. So I can say feed parser, parser.parse URL. Oh, I got to run this. Then I get this. There we go. And then, so this actually has downloaded the data. And then down here, let's do this. I'll print the length of the string representation of this object. So if you call toString on it, this is effectively toString. It will give you the underlying RSS data. So we've got that. Well, what the heck is that? Let's put this into a little string that looks better. We do an F string and put that into curly braces. That doesn't help much, but if we come down here and put a little format character like, then it'll show it's 2.9 megabytes. We could even divide by 1024, 1024, put MB like that. It's even a lot. Let's say 2F. There you go, 2.77 megabytes. It's pretty cool, right? So we've got this data downloaded. Now notice when I hit this one, see there's a little star right here, and then it changes the number from up to 7 to 9. That's it executing. So notice that. What's really different about these notebooks is they don't re-execute the whole thing. Like if I run this again, notice how it's super fast because this is already computed. I don't need to run it again. So if you have like 30 seconds of computation, then you want to explore it, slice it, and dice it. You can do that over and over and over again without actually trying to recompute what that is. So that's pretty cool. Now I put this huge print here so that we don't have to see. I'm going to kind of cheat and just show you the rest in a moment. But what we need to do is we want to get a list of descriptions from this. So maybe the first thing I want to do, actually, I wanted to print out the title as well. So let's go over here and we can say the title is feed. Now this comes back as a dictionary, and there's two ways to get data from dictionaries. I can do it like this, but a safer way is to do this little get thing. So I'll say, give me the feed, and I want, that's a subdictionary. I want the title. Apparently we could say found podcast title. If we run that again, moment, but then found Python bytes. Cool, right? Now I want the descriptions. And in C# we have link. In Python we have what are called list comprehensions. Think of it like a cheap link, like a not as good link. Link is really incredible in C#, but this is pretty close. So what I want to do is I want to get an item for item in, and then we have to go over here and do some sort of query on this feed. So I think we just say get items, and let's just print len of descriptions. All right, that worked. Now this itself is a subdictionary. So in here it has a description that we can get. And let's just print out, here's a cool thing we can do. We can print just the first 5. So we go to description and say just 0:3 to print, say, the first 3. That didn't work. Hold on, let me not do this real quick and see what comes out. We have titles, description. Oh, it's entries, not items. Sorry. Go away. Entries. There we go. And then from the entries, I can get the title. Yes. But I don't want the title. I want the descriptions. Cool. So here's our descriptions. Notice this is all HTML and so on. Now, we don't really want to print that out because that's huge. And I'm going to take this away because I don't actually want to hide the rest. So what we're going to do is we're going to come down here, and this is what we already did. But here's the rest, just for the sake of time, I'm going to show you. So we come down here, we can do this little, get our entries. Here we're going to go through and actually get the entries and then parse the HTML. It's like a HTML fragment. So here we're making it proper HTML. And then here's the link statement. So go through the HTML, find all the hyperlinks, and then select out the hyperlink text, so the URL. Replace www and some other stuff to normalize it and throw those into the links. There you go, your links, and you're sorting it and so on. Let's run it from top to bottom. Wait for that to go by. There you go. So we found 3,029 links. And then we're going to go through and we're going to do what would be the equivalent of a link statement here as well to convert the link into the domains. That's netlock. That's how it is. And then it says, here's the first domains that we found. And then what we want to do is we want to group these. So check this out. All we got to do to say, show me the most common with their count is create a counter object. Say, what is the most common? And there they are. Look at that. Twitter, 218, and so on. And then finally, we want to graph it. So we can use some cool graphing libraries, matplotlib. This I would never type from scratch because I don't know it well enough. But here you go. Here's our little analysis that we got of the site rank according to the podcast, right? GitHub and Twitter and YouTube are super popular. So is Python.org, Medium, Reddit, RealPython, TalkPython, and so on. All right, well, hopefully that gives you a good sense of these notebook types of stories. They're really different than standard programs, and they've traditionally have been very uncommon in the .NET space, but they're very widely used in Python. So here they are. Now, let's see. I think I'll just wrap it up with a few things and we'll take some questions. So the first thing is, let me just throw this link in here. So here's the repo link. Put that into the chats for you all. Cool. So if you want to take the materials, all the stuff you see me write and much, much more is over here. And then also, if you're interested in this, I encourage you to take the full course. So throw that in as well. That is not the right link. It is talkpython.fm/ what was it? .NET Crowd. There you go. Cool, huh? Okay, so this is like a, what is it, 9-hour course that goes way deeper into this stuff and much more of a comparison and touches on all the features. Like we do a bunch of stuff with databases and async and whatnot. But you know, that's, I think you got a pretty good taste of what we're doing with C# and Python. And I guess before I go and answer questions, the thing that I want to leave you with is really that these are actually super similar languages and technologies. Like so many of the things that you would think you really love about C#, you'll find quite similar and nice examples over in Python. Like for example, one thing we didn't cover is lambda expressions. Like they both have almost identical lambda expressions that are super powerful and whatnot. So if you're a .NET developer, check out Python. You don't have to become a Python developer. I didn't say that at the beginning, but that's not the goal of this presentation. The goal is to give you another cool tool in your toolbox and some exposure to some other technology. So that's what it's all about. I'm gonna turn off my screen sharing and just come and answer some questions now. Cool, so let's see, let's go look at the questions here. Yeah, I'll go ahead and take them from the top here. So first one is, are there big differences between Iron Python and normal Python? And how would I use them to work with WinRM? I honestly don't know what WinRM is. You guys are gonna have to throw into the chat or something that's a little bit, it gives me a little bit of, I know WinRT. I have no idea how to work with WinRT in Python though. So Iron Python is a re-implementation of the Python runtime on top of .NET. So it's really the only reason you would ever use it is I want to mix working with code between the two languages. Usually I would think in your world, I have a bunch of a bunch of C# libraries I've already worked with and I like, and I want to use them in Python without rewriting them in Python. So if you use Iron Python, you can basically import, you know, system dot whatever, or like your namespace dot whatever, and it'll like get access to the C# libraries and you just call them. You can also do it in reverse. However, I should point out that Iron Python is not really supported anymore. And so Python, I think it's called Python 4.net. Python is, yeah, Python 4.net. I'll put that in the little chat down here. This is what I would use instead these days because Microsoft stopped supporting or contributing to Iron Python and said, we're cutting it loose. If anyone wants to catch it, right? All right. So there's a couple of questions of what is the thing you want to learn most from this webcast? Well, hopefully I covered it. I did preview this before. One was how to use Visual Studio, not Visual Studio Code, but Visual Studio with Python. So there's Python tools for Visual Studio. And let me put that into the notes over here as well. So if you're using traditional Visual Studio, like Visual Studio 2019 Community Edition or whatever, get this PTVS, Python Tools for Visual Studio, and it will give you like a debugger and like new file, new project, Python options like Flask and whatnot inside of Visual Studio. So that's definitely one. Python Tools for Visual Studio to use Visual Studio as an effective IDE. That said, I would give PyCharm a try. It's much better. Okay. Then Austin asks, top tools, libraries that are useful for Python for web apps. I use a lot of different C# tools at work, but wanting to learn the equivalents. Kind of feel like we touched on those a little bit. If you're building a website, probably Flask is the place to go these days. If you're building APIs, check Fast API. That's got a lot of cool features. Another thing I didn't talk about is newer versions of Python have what's kind of like, it's a little bit like TypeScript, where you can have the untyped Python, and then you can also put type annotations onto the language. So I love to do that. It really helps the editors be more smart. You can run tools that are kind of like what would happen if you compiled it, called MyPy, which is pretty neat, but also like PyCharm will automatically do that all the time as you work with it. The reason I bring that up now is things like Fast API and some of these newer frameworks actually take that into account on how you design the framework based on that. So yeah, it's a cool one. All right, knowing a bit of Python. Let's see. Knowing a bit of Python and nothing of .NET, is there any interest for a Python developer to learn .NET? I think there's some things that are interesting that are worth taking away. Like one thing that .NET is quite good at that Python sucks at is taking an application and delivering it to an end user. You know, you can build WPF or Windows Forms apps that are packaged up and installed ridiculously easy. Like it actually gets built as a byproduct of just running the code, right? You get what you can give to the users. Whereas with Python, you've got to jump through all these hoops to build desktop apps. It can be done, but it's not easy or as effective, and the tooling is not as good. It's also mobile. Like C# has Xamarin, which is awesome. Like our mobile apps at Talk Python are built with Xamarin. They talk to Python backend APIs, but the apps themselves that run on your phone are C# compiled to native apps. So desktop and mobile are definitely reasons that you would care, Dennis. And then, assuming it's technically possible, are there advantages to reap from using Python and .NET in the same project? I'm sure that there are, but I would probably not do it. You could do it with like IronPython or Python for .NET, like we just talked about. Like it can be done, but a more reasonable blend of these things is what I just described. Like that we're doing is we've got our mobile apps written in .NET, but those mobile apps talk to many different APIs on the server for like video delivery and transcripts and history and accounts and all that kind of stuff. All that stuff is on Python. All the mobile apps are in .NET, and that makes a lot of sense. But I wouldn't like necessarily try to push them into exactly the same thing. One thing that might be nice is maybe if you wanted to have like I got a big app in .NET, but I want to allow you to script it, right? I want to allow people who are not really programmers to like write little automation around it. It would be totally reasonable to host Python in there and then take in Python scripts, expose some of your API plugin stuff so they can import it and then go. That might be one, but that's pretty limited. All right, another one. I understand this webcast is for .NET developers on how to switch to Python. We address challenges of Python developers who want or need to develop in a .NET environment. Let me see what I can say about that. I mean, certainly it's a bit of a different world to go between. It takes some getting used to, but I guess the message is still the same, right? Like these things are very similar. You know SQL Alchemy? Well, that's like Entity Framework. You know Flask? That's very similar to ASP.NET. There's a bunch more symbols and a bunch more like middleware goo that's all over the place, but like in essence, they're basically the same thing. So I would say that there's a lot of similarities, and that's probably the most important thing. So just, you know, look around and go, well, what do I need to do? How would I do that in Python? What library would I use? And then there's probably a real similar equivalent there. Yeah. So, oh, my mouse is back. Cool. All right. Well, those are the questions that are already asked. If you have another question, throw it in the Ask a Question section so it like gets recorded in the video. I saw some interesting chats. I couldn't read all of them going by, but yeah, people were saying that Cherry Pie is nice. You guys use that a lot. It had Django is the 800-pound gorilla, but Flask is very elegant and so on. Yeah, I enjoy the conversation, but yeah, if there's anything that you all want to throw out there, add, do it quick. Otherwise, we'll call it a day. Paula says, did you know that C# was designed by Anders Hejlsberg, the guy behind Delphi and C++ Builder? Yes, I definitely did know that. I'm a fan of Anders Hejlsberg. He builds beautiful languages, and he's also the guy behind TypeScript, which I mentioned earlier as well. So a lot of interesting analogies there. All right. Well, thank you so much, James and Dennis. Thank you both for coming, and everyone else. Really glad to have you here. I'll shoot you an email just to like send you some of those links in case you missed them, or also the recording of this will be available on exactly the same URL. You can just come back and watch the recording or share it with people who weren't able to come or something like that. Thanks, Paula. I'm really glad you enjoy the podcast. It's great to have you listening. All right, signing off. Bye, everyone.